Now, in today's lecture, what are we going to cover? We are going to talk about descriptive versus predictive analytics. And we will look at descriptive statistics in details because that's a very important part of analytics. And I will tell you why in one of the slides. We are also going to take a look at some parts of data visualization today. That is, what are, where can you use different types of graphs and charts and tables? So those are the aspects that we will cover today. All right. So let's talk about data and analytic approaches. We had briefly touched upon this from that point. Now we're going to look at this particular picture from two perspectives. One is the data. Depending on the data, what type of analytics would you carry out? So these two are highly correlated. Now, at this end, so the arrow for data is starting from here. So where I will say that the complexity of the data is low. As the complexity increases, the type of techniques that we will use will also become more and more complex. That is, move from descriptive analytics to prescriptive analytics. So that is what it means to say. So this is probably the lowest form of analytics, and this is the most complicated form of analytics. Okay, so that's the first key insight on this. Now, the second important thing is we have to look at data in different dimensions. So what are those dimensions? One is volume. So volume is the size of your data. So we can collect data from various sources. For example, I can collect survey data. I can survey a group of consumers, say 2,000 consumers, and I will get some data points. What are the other sources that you think will, I can collect data from, and that'll be huge amounts of data. So survey data is limited in volume. What type of data do you think will have high volumes? Would be large. We can collect large data sets. Customer database time, you go to Woolies for your grocery shopping, you will notice that all your data, your credit card information is being recorded, whatever you purchased is being recorded. So that over time, if I collate the data over 10 years for all of the customers who are coming into my store, that becomes voluminous data. Then we also have to look at the variety of data. So variety of data is, for example, survey data, the store customer database. So these are two different types of database. What is the variety of data that I have? Can I link them somehow and conduct analytics? So those are some of the questions that marketing analysts and data analysts have to take into account. So marketing analytics professionals are looking for patterns in the data, and the data analysts are actually analyzing that data to provide those patterns. Okay, so you have to understand that distinction. And that is why this subject is geared towards enabling you to understand those key insights from the data. We don't expect you to do any programming. For that, the firms hire data scientists, data analysts, etc. But you as marketing managers are going to use all of that analytics to detect those patterns and make decisions. So that is what you should concentrate. How can I use the insights from this analysis to make the best decisions? Okay, so that talks about volume and variety. Second is velocity. So velocity is the speed with which you're able to collect the data. Where do you think you would observe this type of data? Absolutely. So stock market information comes in real time. Social media data comes in real time. And the difference between the two is stock market data you can still collect in a very structured approach, like, for example, stock price, time, the volume traded, the number of buyers and number of sellers in the market. So there's a structure to that data. But social media data, there is no structure to that data. It could be comments and all comments within comments. So it's very difficult to parse that data. So that's a different type. We call it as unstructured data. Again, YouTube, there's so much, consumers, and more than 1 billion videos released and more than 1 billion consumers on YouTube. So all of that data coming from YouTube viewers, the comments, etc., all of that is unstructured data. So that's high velocity data. Now, together, these three, when as a manager, you have to see that if you have these different types of data sets, you have large data sets, small data sets, you have real-time information coming in, you have to concentrate on the information value. What is that value that you can derive from the data, depending on the questions that you have for you to implement certain types of decisions? You will look at the information, try to get the value out of it by implementing appropriate models. So the models are descriptive, diagnostic, predictive, and prescriptive. Descriptive is the simplest, and about 70% of clients or business managers use this particular type of analysis. And I had recently attended one conference, the Media Federation of Australia, so where there were people from the industry, from consultancies, who were actually discussing this, that even those very complicated techniques are available, but still most of the decisions are taken using the descriptive analysis. And as those who are already working and those who are going to go out and work, so it's really important to get a handle on what descriptive analysis is, because all of your dashboards, your key metrics in Google Analytics, etc., Facebook Analytics, are based on descriptive data. So it might seem low complexity, but you can only imagine the importance of this type of analysis. Okay, so we're going to discuss these in the next few slides. Let's see. So descriptive is like you can just describe your data in terms of mean, median, and mode. So what is the average behavior, etc. Diagnostic is a step further. So in the last lecture, we had looked at creating the models, right? So for example, here is a model. We want to look at the effect of price and advertising on sales volume. So if we want to see, are these influencing sales in any ways, we come up with our own conjectures or hypotheses about how they might be affecting. So for instance, if I raise the price, most likely, the sales are going to reduce for that particular product. So I'm expecting a negative relationship here. I'm expecting a positive relationship here. So diagnostic analytics will do exactly that for you. It is going to confirm or validate your conjectures or hypotheses. So I can run a model and see whether indeed the effects are along the directions that we are expecting. And if they are along that direction, what is, the magnitude of that effect? That becomes important in analysis, because for a store manager, for a retail store manager, be it in David Jones or be it in Woolies or Kohl's, pricing is very important in every industry. So if you're reducing the price by 1%, 0.5%, how much impact will that have on your sales volume? And that is very crucial. And that is why when you have, in mature product categories, you have Coke versus Pepsi wars. Why do you have these wars? Because they're already competing on very low prices, right? There's not much scope to reduce the prices. So they are competing on promotional, they are engaging in a promotional warfare, because the scope of engaging in promotions is not as frequent, even though Pepsi and Coke advertise reduce the prices on their certain products pretty frequently. And the whole idea is to increase the sales. But apart from that, in mature product categories, you will notice that, the competition is based on price, but also on advertising. But in other categories, for example, cars, that is durable products, the competition is based on price. So at, you will notice that end of the year sales, December, there are massive price reductions in the price of cars, especially for 1-year-old model, etc. So because price tends to have a very high impact on sales. So this is about diagnostics, and we are going to see a live example of this. Then, okay, so the whole idea I've already explained here. So we test the hypothesis to see what factors are driving sales. Next is predictive. Now, in predictive, we are trying to see that, all right, I've understood that if I reduce the price, the sales are going to increase. That hypothesis is confirmed. However, by how much should I reduce the price? Should I reduce it by 1% or by 2%? I'm trying to predict what will be the impact on sales volume. And that is what we call as predictive analytics. Okay, well, just give me a moment. So the whole idea is, can we predict the sales if price reduces by 1%? So if you want to do a what-if analysis, that is predictive analytics. Okay, so now I'm going to show you a real example of analytics. So I've collected some data on churn. So in the telecom industry, that is one example of predictive analytics where, credit card industry, telecom industry, here the companies are trying to predict whether the customer is going to churn or not going to churn. So churn means leave the company and switch to another competitor, because you would have noticed that there is so much competition in between the banks that are offering their credit cards. There is so much complexity in the type of credit cards that are being offered in the financial industry. You will observe similar type of complexity in the phone, in your telephone plans that are offered by Vodafone, Telstra, Optus. So that is why in these companies, when customers have telephone operators, they are always on lookout for lucrative deals and they will immediately switch. So that is why in these industries, churn becomes a very important outcome variable, because the firms are always trying to retain their customers. So this is a little data set on churn, and it gives you information about what area the customer is located, for how long they've been the customer, and whether they have an international plan, voicemail plan, voice messages, on their subscription, how many times, how many minutes during the day do they call, how many calls, what are their daytime charges, and similarly for evening calls, what are the evening charges, for nighttime calls, what are the nighttime charges, how many international calls they make, and what are the international charges. And there's another variable here, customer service calls. So how many times does the customer service, do they call the customer service? So now let's take a look. If we want to understand, so we want to do two types of analytics here, diagnostic analytics, and we want to do predictive analytics. So let me select this data. So if we have to identify what are the factors that could be leading customers to churn, what do you think are the diagnostic factors that might be affecting the customers to churn? You have to share the screen so many times. Okay, so I'm sure you can see the screen now. This is the data set that I was describing. This is a telecom company's data set on churn. So here's the information about their international plans, voicemail, etc. How much they are charged for their daytime calls, how much they are charged for their evening calls, nighttime calls, etc., etc. And this is the number of customer service calls that they make to the firm. And this is churn. So the company wants to understand. So this is just like a hypothetical prediction that are they likely to churn or not to churn. but we want to do a diagnostics. Which of these factors, which of these variables here are most likely going to get the consumer to leave the firm? So that's what I want you to think about, that if a customer is going to change their telecom provider, which of these factors do you think might be one of the factors that might influence the consumers to leave? So while you do that, I am going to copy this entire data set into a software that I'm going to now share with you. And I am going to paste the date. Oh, this is PDF. Okay, so I'm going to paste the data here. This software that I'm using is called as Stata. Stata is pretty powerful for large sized data sets. However, if you have like big data, then it becomes limiting. And then we have to use other softwares like MATLAB or Python to be able to analyze those using machine learning. But this is good for, diagnostic and predictive analytics. Okay, so customer calls, yes. So customer calls, if they are very high, we might likely find that consumers are churning. So if I show you this data set, you will notice that there are two different types of variables. One is area, international plan, BMail plan. So these are called as categorical variables because they are in terms of yes and no and labels for the area. So all these are called as categorical variables. Even churn is actually a categorical variable. The others, these are these continuous numbers. This is quantitative data. And wherever you have these decimals, we call that as ratio data. Even this is continuing data, and this could be interval data. This could also be interval data. So whenever you have data sets, it's important to analyze the properties of those data sets before you actually start working with them. That helps you to draw much more accurate insights. All right, so if customer calls and are high, prices are high, our guess is we can hypothesize that the consumer is not happy with the firm. So what I'm going to do is, before I analyze that variable called churn, which I showed you, you can only run the analytics models on numerical data. So if you have these type of categorical data, you have to first convert them into numerical. So the way to do that is, so I have two values in churn, true or false. So I'm going to generate a new variable called churn rate. And this is a bit of programming. You don't have to worry about it at all. Leave that to me. So I'm just giving it a command to generate a new variable called churn rate, which is equal to 1 if the churn is mentioned as a label called true. Okay. And churn rate is equal to 0 if it is mentioned as false. All right, so now let's run a model. So there, our dependent variable, that is our outcome variable, is a categorical variable 1 or 0, which is essentially represents true and false. So when you have the outcome, which is not a quantitative variable, but it's a categorical variable, we run a special class of models which are called as logistic models. So I'm going to run a logistic model where churn rate is my dependent variable. Now let's remove all of these and just put the variables that you are expecting to influence churn. So one of them is the price. So let's put day charge. And then let's put evening charge, another variable. And then there is the night charge. So we can predict that in general, if the prices are high, then they're going to predict. But what if what we don't know is which of these prices are going to affect the most. So let's see whether it is the day prices, evening prices, or night prices. So I'm going to run this model. So what do we, so just give me a moment to show you interpretable output. Okay, so this is the output of the model that we have run. So here what you will notice is day charge. So if day charge increases, the consumers are going to churn. And if customer service calls increase, the consumers are going to churn. So I'm going to go in more details. Let me take this output and print it onto the slide so that we can then compare predictive and diagnostic analytics. Okay, I'll just put it on my slide. Now, I am going to come back over here. So we have found that there are two factors, day charges and customer service calls, that are increasing the churn rate. Now I'm going to discuss these, but let's do one case of predictive analytics. Now that we know that these factors are affecting, let us see if the customer service calls or if the day charges, let's say the day charges reduced by a certain number. So let us see the unit of day charges. So these are 45, 50, etc. Now the data does not have description whether these are dollars or cents per minute, but let's assume that we just reduce, say it is 45, let's reduce by 10. So let's say the day charge reduces by 10. So I'm going to generate a new variable called day charge 1 minus 10, because now I want to predict what will happen if the day charge reduces. So what do you think? Do you think it's going to have some effect? Can we make some guess? So let's run this model and see what happens. Now you will notice I have the new model after incorporating the predicted price drop. So here is the effect. So it is 0.039. So now let me just copy this output and then we will discuss it onto the slide. Okay. Now I'm going to stop sharing that screen. So the whole idea of this software was to demonstrate to you how we engage in diagnostic and predictive analytics. And I will come back with that output and share the screen on the PowerPoint. Okay, so here we have the diagnostic output that we had looked at. So what we found was, whenever we are looking at these outputs, there are 2-3 important things that we have to take into account. Okay, so first is, if we are, say, looking at a variable, does it have an impact or not? So we have to first look at the hypothesis testing. So in diagnostic testing analytics, we were trying to say that day charge is going to have an effect. So usually the significance is set over here. So if this particular column, if the numbers in this column are less than 0.05, we can confidently say that yes, if the day charges, the impact of day charges is significant. Okay, so which means that if day charges increase, so it is 0.039, if day charges increase, the churn is going to increase. Similarly, so this variable is higher than 0.5, so this is not significant. It has no impact. Night charge is also higher than 0.05, so we say that it has no impact. Customer service calls, yes, definitely this variable is less than 0.05. And yes, it is an influencing factor It is an important diagnostic factor that influences churn. Day charge is on the periphery, it's just at 0.05, but still we will say that it is an influencing factor. So these are the two factors that our diagnostic analytics has uncovered are affecting the churn rate. So if customers are making too many calls, if the firm's data and charges are high, then consumers are going to leave. And so the manager can appropriately design strategies. So either you can reduce the price and offer some, loyalty, design some loyalty programs for consumers who have been your customers for a long time and offer them reduced rates, or you offer reduced rates to attract new customers. It just depends on the context that you are looking at the problem. Definitely, this is a concern. If customer service calls are very high, then probably you have to train your sales staff better or engage in some actions that will, make your customers happy. Now, predictive analytics. So we had reduced the day charge and we wanted to predict what will happen if we reduce the day charge by 10. So it is significant after we ran the model. It is still a significant predictor. So is customer service. But was there any effect in this? Let us compare it with the previous output. So this was 0.0392533. After we reduced the price by 10 units, it still remains the same. So that means this much drop in the price is not going to have on any effect on churn. It is, if at all, going to have a minimal effect. So consumers are still going to churn. How about the number of customer calls? That is another thing that we can try. If the number of customer service calls reduce, then what is going to happen? So we can engage in a similar exercise where we generate a new variable for customer service calls by incorporating a drop in the calls and see whether that has any effect in the churn rate. So this is a very rudimentary example to illustrate to you how we engage in diagnostics and predictive analytics. Now we move on to our next concept. That is, so we have compared diagnostic with predictive analytics, right? Descriptive analytics, let us see what is the key difference. I'll just change my pointer. Okay, so when we talk about descriptive analytics, this is the lowest complex level of analysis, which means we are just looking at mean, median, and mode. So what we want to understand here is the occurrence of certain business phenomena or outcomes. So for example, the companies have this concept of agile working in the workspaces. So what does that mean? It means that every day when you start your work, the entire team for 10 minutes will stand together in a group, and each of the team members is going to say that this is the amount of sales that I have successfully generated for my area, right? So you are discussing the outcome. You are just talking about the average sales in your area, or how much did your sales increase yesterday as compared to day before yesterday. So you're looking at those day-to-day, numbers which are important for you. So that is about descriptive analytics. So to explain these outcomes, you will use the most rudimentary, the basic numerical analysis, which is actually very important and very, you should be very thorough and have a good understanding of that. You will use graphs, you will use charts. So it is definitely very important to be an expert in this particular area of descriptive analytics. And descriptive analytics is very, very useful to identify patterns. And you will notice, and so I'm sharing my experience as a researcher and also for data scientists who are working in the industry. The most complicated analytics always starts out with descriptive analytics. First, we have to see the patterns in the data to be able to make some hypotheses or conjectures and then validate them by running our models. So that is why this, I cannot emphasize the importance of descriptive analytics enough. Okay, predictive analytics, I have just demonstrated that example to you. So we want to predict how the customer is going to behave. You want to group the customers. So this is a type of predictive analytics that you're going to do in marketing analytics course. It is called as clustering. So when you are trying to understand a market, you want to, roll out loyalty programs to customers, but they are all different, or you want to roll out an innovative product into the market. You have to understand who will be your customers who will go for that innovative product. So you have to slice your market, or you have to segment your market, which we do using a technique called as cluster analysis. And that is something that you're going to do in Tableau in the subject. We also use econometric models. So the model that I just showed you, logistic model to predict churn, is a very popular model used in the industry by these firms which are interested in predicting churn for telecom customers, credit card customers, and in numerous other contexts. So there are different types of econometric models. They are used to study different contexts and different problems. AI and machine learning is used to engage in predictive analytics for very, very large data sets, which we discussed on the previous slides: structured data, unstructured data. So now let's come to the important part, that is the descriptive analytics. Now, descriptive analytics is of two types: the measures of central tendency and dispersion. Go back. Basic idea around measures of central tendency is that, for example, if let's say you are the manager of Kohl's, on a day-to-day basis, you are observing that consumers come to Kohl's and they purchase the products, right? You notice that some consumers are buying $5 worth of products, some consumers are buying $10 worth of products, some consumers are also buying $100 worth of products. So if you have, say, 1,000 consumers coming to your store on a daily basis, you want to figure out, can you describe the average spending? Can you describe the spending of these consumers in a certain way? So if I'm using average spending, that these consumers are coming to the store on a daily basis and spending, say, $3 on an average, that is descriptive statistics. That is called as mean. Median is the middle number. So when I'm looking at all of the expenditures and I arrange them in ascending order or descending order, and I pick out the middle number, that is called as median. Mode is called as what is the majority, what is the number which is being most frequently observed in this spending data set. Are you observing $10 spending by most of the consumers? So if 1,000 consumers are coming to the store, let's say 500 are spending $10 in the store. 100 are spending only $100 in the store. The remaining are spending $3 in the store. So things like that. So if you find that a majority of consumers, 500 consumers, come and spend $10 in your store, then that $10, that amount of spending is called as the mode, right? So the mode of spending by consumers is $10. Average spending is $3. So the whole idea of this is that if you have a huge amount of consumers coming into your store, you want to figure out the basics of describing that data instead of having to look into every individual consumer's spending. So where would you use median? Where would you use median values? So average can be used to describe spending. In what context would you use the median? Median price, median spending history. So if you look at the real estate prices, house prices in an area, in the same suburb, you might notice some houses are 1 million and the other houses can be as high as 7 million. So for a consumer who's looking for a 2-bedroom house, and all of these houses are, say, 2-bedroom houses. So for a consumer who is looking for a 2-bedroom house, the median is the right number because obviously the price of a house of $7 million would depend on probably the location, the surroundings, etc., etc. So a lot of factors might influence those high prices. And when you take an average of extremely low and extremely high prices, the average of those prices tends to get distorted. So that is why in real estate industry, average price, if a real estate agent is talking in terms of average prices, you should know that, yeah, that's not the correct indicator. You should look at the median prices, the middle number. So the middle number indicates that 50% of the consumers have bought houses. Let's say the median is 3 million. So median is telling you that 50% of the consumers have bought houses which are below 3 million, and 50% have bought houses which are above 3 million. So that is the importance of descriptive statistics in terms of central tendency. Okay. Now, mode. I will give you one insight about mode, why mode is important. So, for example, if you take a look at the consumers who are coming to your, say, Kohl's, who are going to Kohl's and they are spending in the store. Now, there are 500 consumers who are spending $10 in the store, and there are another 500 consumers who are spending $20 in the store, and the remaining are spending less than this or more than this. So what happens is when you plot the prices on a particular day over time, you will notice that this is how the prices will look like. This will be the pattern in the data. So this is $10 spending, and this is $20 spending if you plot the prices. So this is the mode. So this is called as bimodal data. So modes are important to detect in the data because they tell you about segments of consumers. So there are likely to be different types of segments in your store that are coming and shopping. So it's the managers can then further drill down. So if they are spending on, this segment is spending $10, what are they buying? If they are spending $20, what are they buying? So if you look at their purchases, you can design promotions or loyalty card schemes accordingly. So that's the importance of understanding descriptive analytics. Okay. The next part that we look at is measures of dispersion. So measures of dispersion are also very important, and these are range, variance, and standard deviation. So why are measures of dispersion important? So if you have a data set where, let's say consumers, you are working in the hospitality industry and you are a restaurant manager, and on a daily basis, you have consumers coming and filling out, eating meals and filling out consumer surveys of satisfaction. How satisfied were they today with the meals and the service? And you're asking that on a range of 1 to 10. And you notice that a lot of consumers are giving a score of 6, but there are some consumers who are giving a score of 1. There are some consumers who are giving a score of 10. So there is a lot of variability. Now, this variability is important to capture in the data. That is called as dispersion. So if the consumers were really happy, on an average, if the consumers are very happy coming to your restaurant, you will notice that their ratings will be very close to one another. Say, let's say 8. Most of them will give a rating of 7, 8, 9, or 10. But if some consumers are very unhappy, some consumers are extremely happy, you will see large dispersions in the data set. That means you have consumers coming to your restaurant who vary in their preferences and their tastes and the customer service levels. So identifying dispersion. So if the dispersion is very high in customer service, it means that the restaurant has to take steps to identify why some consumers are not happy and why some consumers are extremely happy. So how you can improve the satisfaction levels for consumers that are not happy. So that's the whole idea. So when we talk about range, range means comparing the lowest score and the highest score. So let's say in this data set, the lowest score that you have got is 7 and the highest is 10. So here your range is equal to 3. But let's call this as A and let's call this as B. Now in data set B, what is the range for data set B? So range is the difference between the highest and the lowest score. Yeah. So here the range is 9. So the higher the range, that means higher the dispersion in the data. And if there is very high dispersion in the satisfaction levels, it means that some consumers are extremely happy, some are very unhappy. So that means the manager has to pay special attention to factors which have high variability. So that's the whole idea. And similarly, variance and standard deviations are similar measures. And mostly in the industry, when we are looking at figures, we are looking at the range and we are looking at standard deviation. So standard deviation captures the distance from the average for every observation. And that is another different measure of variability, but they give you the same information. So for this, there are standard formulas. You don't have to memorize the formulas for variance and standard deviation. Those are usually available in the CAN packages, and we are going to see that in Excel how just using a simple formula of stdev.s, you are able to calculate the standard deviation for a column which has, say, 1,000 values. So don't worry about the formula, just understand the concept. Okay, so let's move on. Now we're going to move towards data visualization, and data visualization. So what we talked about in the previous slides was a lot of numbers, right? We saw a lot of data, we saw a lot of numbers to describe the data. However, a lot of research indicates, and you will notice from your own personal experience, that it is easier to understand visuals rather than understand the data. So whenever you are presenting the key insights from the data, it is always good to use visuals rather than a lot of numbers. And as they say, a picture is worth 1,000 words. So remember that. Okay. Now, here are some research findings that 90% of the information transmitted to the brain anyways is visual. So that's why when you are in your surroundings, you tend to observe and remember things rather than memorize and remember things. 40% of the people will respond better to visual information than plain text. And that is why when you go to the grocery stores or David Jones, etc., you will notice that you are less receptive to their flyers, but more receptive to the end of aisle displays when you're actually in the store, because visual information tends to have a greater impact. 96.7% consumers believe that visual content engages best on social media: TikTok, Instagram, Pinterest, Facebook, YouTube. So YouTube is becoming one of the largest video content sharing websites, and the short form videos are becoming extremely popular. But having said that, it's not about which is becoming the most popular, but across all of these websites, the ones that are transitioning towards more visual content are gaining more popularity. Twitter, we have to see, Blake, how Twitter goes, because it's still kind of, for strategic reasons, it's still undergoing a sort of an evolution. So yeah, we'll see where it goes in the next few years. All right, so now let's move to the basic design principles when you're describing your data. Always remember that when you have to look at your audience, so not everybody to whom you're describing your data will love numbers. So you have to organize the information accordingly. So if you are possibly presenting your work to researchers, it's a great idea to show numbers, because that is what they will pay a keen have a keen eye for. But if you are presenting your work to, let's say, executives of a company who are only wanting the key insights, then it's best to present visuals. Whatever you are presenting, do not bury the key message in the mass of details. That is very important. So your key message should be bold and flashy. Then accurately represent the data. Avoid distorting or misrepresenting the data. Use clear, detailed, thorough labeling. So the whole idea of this entire paragraph is that when you're working with data, you're essentially engaging in statistics. Now, it is very easy to misrepresent the numbers and use them to your advantage. And that has happened at very high scales and has brought down the firms, for example, Lehman Brothers. So they were engaging in malpractices of using the data, and that was discovered by the auditors. So it happens at every level. So it's very important to maintain the ethics of using and representing the information with that data. So you have to always remember that, because if you do misrepresent the numbers for short-term gains, you are likely to end up with more long-term troubles. And also having too many numbers will create a lot of clutter on your slides. So it's always good to balance them with visuals. So here's an example. So this is a social network graph, which has been plotted to understand what consumers are talking about the different movies that were released at different points of time. So these are 3 different movies: Matrix, which came in 1999, the Twilight Saga, and It's a Wonderful Life. So how many? Okay, so now Twilight Saga became a big sensation. It was one of the most popular movies of its time, and so was Matrix, actually. So here's a look at what were the characters that people were talking about. So instead of printing numbers, what the data scientists have done is created a graph from social media networks. They have taken that entire unstructured data and they have pulled out the words that the consumers are talking most about. And it turns out that for Twilight, the consumers are talking most about Bella, and then Edward, and then other characters, other actors in this particular movie. So mapping the individual consumers' connections to their other friends in the network and the topics that they are talking about, these maps are created. These are called as social network graphs. But the idea here is to illustrate to you that it is easier to understand in the social media dynamics by creating these graphs rather than going through millions and millions of those comments. So that type of data we should just leave to machine learning. But as managers, we need to look at these graphs to draw insights. Now, in the social network graphs, the bigger the circle, that means the more that actor or the node is being talked about. So these circles are called as nodes, and these lines are called as edges on these social network graphs. So out here, the bigger the node means the more these characters are being talked about. And the more dense the networks of lines is, that means that many more number of people are engaging in conversations around the actors involved in this movie. So as you can see over here, It's a Wonderful Life. Probably it must have been really popular during those times in 1947 when it was released. And so there is pretty intense conversations around this movie. But I'm also wondering, around that time, there was no internet, so probably there might have been a re-release version of this movie, or probably it might have, for some reason, generated conversations in the internet age. So that is about, visualization of complex, dense data, especially in the networks. History of graphical representation. So I'm just going to briefly just run through this slide. But the key point to note here is that visual representation has been around for a very, very long time. 600 BC, before Christ, they had these tablets which had the maps of the world. How amazing is that? 276 BC. So here is, another map. That's pretty fascinating. Coordinate geometry came in 1300s. And 1700s, William Playfair was using bar charts and pie charts to, describe imports and exports and trade, right? So, yeah, it's kind of very interesting to see how visual representation has been evolving over time. And then you have Florence Nightingale. So how many of you have heard of Florence Nightingale, and in what context have you heard her name, if at all? Florence Nightingale was she became famous as a nurse. She was actually a statistician by training, but she was in the medical profession, and she became very famous as a nurse during the Crimean War because she organized during that war some camp to look after the people who were injured in the war. But she had, created this Nightingale Rose diagram, which was used to represent the different types of injuries that people had during the war times. And the biggest slice on this rose diagram represents, a particular type of injury that must have occurred in high numbers in a particular month. So that's the whole idea. So this is a rose diagram, or a circular histogram, as we call it. Okay, then we come to data description in terms of tables. So tables are, again, they are great to communicate to a mixed audience, but again, you have to look at what a majority of consumers, majority of your audience are like. Do they like numbers? So if they like numbers, it's a good idea to put in some tables there in your presentations. Also, tables are used. Simple tables can be good to compare, across different categories. If there are, for example, if there are differences, let's say demographic differences between Sydney and Melbourne, or real estate house prices, how they are moving up or down across different cities. So sometimes tables can be helpful, but it's always good to present them in a way that they come across as appealing. So here are 3 tables. Which one do you like? Heavy borders, Madeline? So minimum borders is the one that is most preferred in the academia. So we generally tend to remove any sort of jazz elements or shadings from the table, so that the numbers are, they pop out. So yeah, but in the industry, they generally prefer tables with light borders, just to make them visually appealing. So that's the whole idea. Okay, good. Now we come to line graphs. So we are going to look at different types of graphs and under what conditions we tend to use those graphs. So the first type of graph is a line graph. And a line graph is very useful when we want to track changes over time. So this is an example of the population, how it's been changing over time in different areas. So you have Broome, Kimberley, Halls Creek, etc. Can you think of one industry where line graphs can be really useful to track changes over time? So another industry where you can use it is finance industry, to see the number of subscribers for credit cards or stock price movements, etc. But stock price movements have very high volatility, so they are for the experts to interpret. So, but yes, you do use line graphs there as well. Okay, so here is an example of line graph. Now, this graph shows the population for area C, which is a blue line, and area D, how the population of the 2 areas has been changing over time. So what do you notice here? So I'll draw the center line to separate the data. So what is the trend that you notice? Or what is the pattern that you notice in this data? So area C is declining, yeah. Area D, the population, is increasing, right? So it is correct. When we look at this particular graph, we notice a downward trend for area C and an upward trend for area D. But notice that the graph has started, the starting point is 380,000. It is assuming that the population is of this area initially when the area was habitated was 383. Okay, but the important point I'm trying to highlight here is that this graph has taken as a starting point a population of 380,000. But see how the picture is going to change when we actually include a zero, because if you are tracking the change of population over time, you have to have, it's important to include a zero on the vertical axis unless it is necessary. So this is the key insight here, because having a zero on the axis of the main variable can change the way that you can look at the graphs. It gives you a true picture. So as compared to this graph, now what can you say? The gap between the change in population is not as wide as it was showing in this picture. It is pretty narrow. So there has been a change in, there has been a decline and there has been an increase in the population, but that difference is not as drastic as it shows over here. So it's very important to have a zero on your vertical axis unless it is necessary. Okay, that is the key point here. Line charts are not suitable if you have very few data points. So if you have just 2-3 data points, it's better to use bar graphs. Okay, then we come to graphs now. So this, what you notice here is a bar graph. We call it as the vertical forward. This is a vertical bar chart. Now, how this is very useful to display categorical data. Now, that categorical data is important because, those are not numbers. They're just simply labeled. So, for example, in a school, the number of students who choose to play musical instruments, sing, dance, or engage in drama. So you can see a distinct pattern here that much of the preference for school children is for playing a musical instrument. So can you translate that to a marketing scenario where you think you would like to use vertical bar charts or any type of bar charts, and for what type of categorical data? Where can you possibly use this chart in a marketing scenario? For doing tactical marketing in a store, manager would want to see how many people bought products that were on display. Yeah. How many people bought products that were in newspaper adverts? How many people bought products that were on in-store price reductions? Sometimes stores don't advertise, but they have some in-store specials. So in those categories also, then it tells you which of your promotional tactics is more successful in drawing consumers to store and getting them to buy products. So that is another example. Okay, let's move forward. Now, the advantage of bar charts is you can combine the categories. So if you have several categories over time, so now here, my example can be combined with Tu's example. That is, if we want to see the effectiveness of different tactical promotions over time, over weeks. So here is newspaper advertising, end of aisle display advertising, and we want to see it in week 1, week 2, week 3, week 4, that is across the month. So that's a very powerful way of comparing the effectiveness of promotions in a month for a store. Okay. So these are more demographic examples here. I'm trying to give you as many marketing examples that I can possibly give you. So here, just another key insight I want to illustrate over here is that when you are comparing categories in a bar chart, you can see the trends not only within a time period or within a location. So for example, this is the indigenous population trend in different areas. So you can see within Broome, it is increasing, and overall it is increasing. So Broome is much in line or contributing to the total population trend. But the pattern here in Kimberley is a U-shaped pattern. So it was high, then went down, and again, for some reasons, it has started increasing. So Windham, East Kimberley is in the direction of the total trend. So these are within categories you're able to understand what is happening. So for example, newspaper advertising initially attracted a lot of consumers, then went down, and now it started picking up. So you know that possibly there could be something else happening within the segment of consumers that gets attracted to the store through newspaper advertising. But we can say for sure that if you have, let's say, end of aisle display or catalogs going to consumers, there's a very clear upward trend. So you want to engage in this type of promotion more than in this type of promotion. So those are some of the implications of using these bar charts for comparison. Okay, here's another interesting one. And in this bar chart, sometimes you have to see, other than the individual category trends, you know, upward or downwards, it's always good within the same region, across the regions, to see the negative trends and the positive trends. So these type of bar charts, they can be horizontal or side by side, and they help to see you, you know, get that picture very clearly. So if you will see over here that the net internal migration is actually negative, but net overseas migration is positive, and natural increase is of course higher than the net overseas migration. So this has implications for public policies that governments create for us based on the population growth, and which is why at times the government has to control the overseas migration if the internal population is sufficient enough to sustain the economy or lead to growth of the economy. So there are a lot of macroeconomic factors that you know, determine the overall migration levels. Okay, so in terms of you know, marketing, I'll give you an example of my own research study. So with my co-author from University of Sydney, we had collected data on consumer behavior reports from the US across all of the categories that are covered by that report. So essentially they are, you know, review ratings given by experts of that company, and consumers read those review ratings and then they decide whether or not to buy products. So we tracked the ratings across all of the product categories like vacuums, white goods, paints, and many other different types of categories. So there were about 30 categories over time. And the time period was 25 years. And we, you know, created a plot that was something similar to this. So we were able to identify which of the categories were actually negatively performing and which of the categories were positively performing over time. So just simply based on the review rating. So that kind of gave us an idea about the amount of innovation and product development that happens in those categories. Okay, so now let's move on to the next slide. So here is a bar chart. What do you think about this? How informative is this bar chart? There are lots of lines. It is a bit confusing. So, you know, it's a pretty, it seems like there's too much action happening here on this particular graph. The information is hard to gather and see. So this is an example of exactly what you should not do when you are creating graphs. There's just too much information happening on here. Now, when you come across these type of situations, what you can do is you can pick up the main insights and present them in a graph for better visualization. So just pick up a few categories and show them. For example, here. So if you look at on the left-hand side, the green and the blue bars, they are pretty predominant and they represent heart disease and cancer. And so you can take those two categories and represent in a much more simpler fashion, easier to spot the trends in the graph. And you can simply put a note that we observed an increase or decrease in other categories as well. So visual representation is very important, but it has to be meaningful. So